All right, first what we're going to do is we're going to model in a flange plate here to provide our connection between this beam and this column. We'll go ahead and go to the beam properties, and since this is going to be a rectangular plate with no cuts or corners or anything like that, we'll just go ahead and load up the plate properties here, and we'll use this plate 1/2 by 12 inches. We're going to go to the position tab, and we want the rotations to be so that way we're looking at the front or the width of the plate, and then we want the depth to be front, so that way it's coming up at us, and we'll press apply and OK. Now we've got the steel basically positioned here at the top of the grid or the top of steel, and if we get into a plan view and then we come in here and turn on our snap to geometry lines and points, we can go ahead and snap from the midpoint here of the flange, then right click and say nearest, and then type in 12 using the numeric snap, and now we have our plate here input into the model. Now technically all we need is one part or one object in the model in order to define or create the custom component. So here we've got this plate, and I'll do all of the other work as far as cutting this back and putting in bolts, etc. I'll do that within inside of the custom component editor. So we'll select on this part, and then we're going to come over here, and in the applications and components panel we're going to click this button and say define custom component. Now we are doing a connection, and so I'm going to go ahead and call this my connection. And you need to make sure that your name is unique. No other custom component can be called with the same name, so you just need to have a unique name there. And then on the position tab, we're going to leave everything here as default. If you were doing a splice, you might do an ended plane for the position type, and I'd suggest pressing F1 on this dialog box and looking at the help to understand some of the explanations on the different position types that you can use here. Now on the Advanced tab, there's this checkbox, allow multiple instances of connection between the same parts. This is if you're actually trying to use the same custom component connection multiple times between the primary and the secondary. You don't usually want this because you don't want connections on top of each other, so I usually leave this unchecked. Alright, so we've got everything set there. We'll press next in the wizard, and then there's the component objects. So again, these are the objects that are going to be created by the custom component. We'll select that there, press next. The main part is usually going to be the supporting member, then the secondary part, and notice it's plural here. So you have to have at least one secondary part picked. If you had more than one secondary, you would hold down Control and select those additional parts. So here we only need one, so we're just going to select this one and press Finish, and now we have a new custom component. Now again, there is some sort of bug here within Tekla Structures 2017 to where you need to change the selection toolbar off and then back on again, and then that way you can actually highlight your component here in the model. Again, if we double click on this, we can see that there is a general tab that allows us to control the orientation and positioning of the component. And then here we also have a connection code. So even with custom components, we can make connection codes if we need to. Now let's go ahead and apply our component to other beams here in the model. So if we go into the ungrouped items, we'll see my connection. If we click on it, it activates it. It says pick the main part, so that'll be the column, and then it says pick the secondary part. So we'll pick this beam here. It says pick column, pick secondary part, pick column, pick secondary part, and when we're all done, we'll right click and say interrupt. Now, what you'll see here is that this component works really well when it's the same size main part as well as secondary part, and it'll basically maintain itself. Now, when the beams are framing into the column web, notice that the positions are a little bit offset on that plate. And so things may not 100% work for a custom component that we make on the column flange versus the column web, depending on how we do the bindings and what we're exactly looking for here. Now, the other thing that we would want to watch out for is, let's say that we change the beam size on one of these secondaries. Again, notice here that the plate moves down. So part of what you're doing before you make anything parametric on your component is you want to see what just the generic custom component will do. How does it change based on the column size or the beam size changing versus what you originally defined or made the component with. Alright, so with that in mind, we're going to go ahead and start making this parametric. And the very first thing that we'll do is we're going to bind this plate so that way it always stays in line with the top flange no matter what beam size we use. Alright, so to edit the component, We can select on the component and right click and say Edit Custom Component, or over here in the Applications and Components panel, we can right click over the icon and say Edit Component. This opens up 4 views here that are prefixed in their name with Custom Component Editor. We want to make sure that if there's any main modeling views like this 3D view, we want to make sure that that's minimized so that way we don't accidentally do any modeling in that view. Basically what's happening is in Tekla structures, this custom component editor windows or views are created off in a distance away from the main model. They're temporarily there while you're within the editor, and when you close out the editor, this steel and these views are deleted or they go away. Now you want to make sure you model in here so that way any of the modeling and objects that you do are here in this location where this temporary copy has been created. So this is something important. Make sure you don't model anything here in your main 3D views or any of your main modeling views. You want to only model in any of the views that have the prefix in the name Custom Component Editor. Now that we do have the views minimized from the main modeling, we can go ahead and tile vertically so we're just working within our custom component editor views. A custom component editor toolbar appears, and a couple of the buttons that matter most is over on the right there's this close button which will close down the editor and bring you back to the main model. Now 2 other buttons here is there's this display custom component browser. That's what this dialog is here. So if we close this down, press this button, it'll open that dialog box back up in case you close it. Now, this is basically a tree view. So underneath this, you're going to see all of the different inputs as well as objects that were created by the component. So if we go to input objects, we're going to see a primary and a secondary. It's interactive with the model. When we highlight those here in the tree, it highlights those objects in the model. We can actually get access to any of the profile properties and things like that, which we're going to see is going to come in handy when we want to affect the width of the plate later. Now, under the component objects, this is basically any of the objects that are created when the custom component connection is applied in the model. So here, this plate is created when we apply a connection between the column and the beam. All right, the next thing we're going to do is if we open up our variables list. So this is basically what I call the brains of a custom component. This is where any of the parametric bindings are going to appear, where you bind plates or objects to surfaces of parts, or any of the formulas and fields that you're going to have on your dialog box, such as the plate thickness or changing the material grade or the name. All of those will be managed here within the variables list. So again, this is the brains of the custom component. And just to show you, basically if we add a parameter in here, and we do something as simple as 3 plus 5, in fact, we actually need to start any formulas with an equals, but 3 plus 5, basically we see this 5/16 value. So what's going on here is basically any numerical values whenever the value type is a length. If you're in the imperial environment, these direct numbers like this represent millimeters. So it's adding 3 plus 5 millimeters together and gives us the resultant value of 5/16. Underneath value type, we can see that there are a variety of different types. These are some of the different value field types that you're going to have, such as text in order to enter a part name on your dialog box, or a material value type which allows you to open up the material catalog and select a material grade on your dialog box. Same thing with profile, opens up the profile catalog, etc. Bolt size and bolt standard and bolt type, so that we have the drop downs of selecting a field bolt versus shop bolt, what's the grade of bolt that you're using, and what are the predefined bolt diameters that you might want to use. So this value type is pretty important, and you're going to see that I changed that quite a bit. Now, if there's formulas that are being hidden behind the scenes that you don't want to appear on your dialog box, then you just say visibility hide, and it will not appear, and it'll only be a formula here with inside of your component. If you do want it to appear in your dialog box, you select show. Then here, this is the label of that value in the dialog box. So if we wanted something in here, for instance, to be plate thickness as an example, we could say plate thickness, and then let's just come over here by default and say 1/2 inch. And so basically this will be the default value for the plate thickness in this custom component, and that will show up as a label of plate thickness in the dialog box. So again, these are all the variables and formulas and pretty much the brains behind your custom component. Now, before we do anything more with parametric variables and things like that, let's actually do the binding. So when we were in the model before, when we changed the beam size, the plate was moving up and down. And what we wanted to do is we wanted to constantly stay with the top flange of the plate here. And so what we need to do is, you see that I modeled the plate so that way the input points here are lined up perfectly with the top of the flange. Like if I go into any of the other views, you can actually see that the plate is positioned there. So let's say over here, the color is yellow, so it's a little bit hard to see, but you can see the bottom of the plate and the picking points are lined up. All right, so what we do with this is if we select on this point and we right click and say bind to plane, and basically we need to be in fully solid rendered mode. If we come in here, there are 4 different plane types that or 5 different plane types that we can work with. I'm going to go ahead and walk through each of these and why you would use different ones. So basically, if I've selected this point and I say bind to plane, you'll notice that there's first this boundary planes. So basically around every profile, there's a boundary box. And if you don't really need to get to the specific web or anything like that, then the boundary box is good. Here in this case, we're just going to the top flange, so we're just going to bind it directly to that top flange, and this boundary plane would be fine. So if we wanted to bind this, we would just simply click on that plane when it's highlighted, and then a distance or binding would be created. Now, before I do that, there are other types of planes that we can bind to. I can also bind to the center planes. So here's the center of the beam. There's also the center of the column, and you can see that there are center planes in all 3 directions, including at near the midpoint of the beam. So this is one thing that's important, is when you think about this and you're working in 3D and you're binding points, you're binding them in 3 dimensions or 3 different planes typically. So here we actually could even bind this to the center of the beam. So if the beam was slightly offset from the column and we wanted to define where the plate should be centered to, we could say center it to the column, or we could say center it to the beam. Then there's outline planes, and this is great if you want to get to the very specific planes of the profile, like the web or the inside flanges, etc. Then we have something called cut planes, which I don't use very often, but you can bind to cuts and things. And then here we have component planes, which is also handy. Whenever you have a connection, depending on the position type that you set in the wizard, usually these planes are basically at the center or the intersection between the primary and the secondary. Sometimes you will find it handy to be able to bind directly to this, especially if there's like skews or certain things that are going on. You may end up wanting to use this. Now in this case here, all we really need is boundary planes. So we're going to bind ourselves here to this top flange, and when I click on it, it creates a distance in the model. So there's this little dimension that basically appears here. And right now you can see that the dimension actually zeroes out or touches each other because, again, the picking point here of this plate is lined up directly with the top flange. Now, this is really great. If I can basically bind or glue the surfaces and the points of these plates to the beam flange and get 0 values, this is good. When I have a non-zero value, like if I'd have modeled these points at the top of the plate, I would have had to do something here with the formula, like on this distance, to account for the thickness of the plate changing. So again, whenever you're planning out your custom component and you're doing bindings or gluing points of objects to other objects or surfaces of other objects, you want to try to design the inputs of your parts and things to where you have to do the least amount of formulas here as possible. So let me show you an example of this. Like if I delete out this binding here and then I change the position over here to let's see, behind, and then I'd actually move that plate up 1/2 of an inch. Okay. Again, now the points are 1/2 inch above. They're based on the plate thickness. So if I right click and say bind to plane, make sure I'm fully solid here, and pick that, now I have a 1/2 inch value. And I'd actually have to go get the P1 value here and say equals P1 for that to constantly be parametric. And so that's just more work and more management for me on the custom component. And I don't really want to do that. So again, I'm just going to undo back here. There we go. And then we'll just go ahead and select on that, say bind to plane. We'll go to that top flange, and now we've got the 0 for our binding distance. Now, let's go ahead and bind at this point in the other directions, so to the other planes. We're going to right click, say bind to plane, and the next one we're going to do is center planes. So I want this to follow the center line of the beam. So I'm going to go ahead and bind it there, and that again gives us a 0 binding dimension. We can see it here in the plan view. And then we'll do one more binding, and that's actually going to be to the boundary plane of the column flange. So here, when I go ahead and click on this plane, what it's going to do is it's going to say that this point always needs to be a certain distance or follow to the flange of the column. Now, this is one of those cases where I do have a positive dimension, and I need it to be a positive dimension because we need a positive length for the plate there. So I might actually add a variable here, and I might say plate length. And I want that to appear in my dialog box. Now usually what I do is I keep all of the distances or bindings, so anytime you see a variable here in your list with a D as a prefix on the name, that basically means it's referring to a distance or a binding in the model. I usually keep these all hidden here, and I manage all of my inputs using parameters or things that start with the name P. And again, you can change the name of these parameters if you'd like to. You can call it whatever you would like. But basically, I oftentimes just leave it at the P's, and then I change the labels in the dialog box over here to manage this. So let's say that I want this to be 8 inches here. Okay. Now, if on D3, I basically want it to refer to this. So let's go ahead and change this back to P2, sorry. So on P2, if I want that value to be here in this binding, so that way it uses that for that distance, I'm just going to go ahead and say equals P2. And now you'll see that that distance has changed to 8 inches. Okay, so let's go ahead and repeat these bindings on this second point here on the part. So we'll just click on it, right click and say bind to plane. We're going to bind to that column flange, to the beam flange, and then lastly to the center planes of the beam. We'll interrupt when we're done. And now when I come into the variables list, we should basically have 6 bindings here. So 6 variables with the letter D as the prefix, which we do. And so what's really great about this too is if you actually highlight each one of these, you'll see that it highlights it in the model. So that way you can double check and make sure that the points are all input here. Now this is a good thing to do. Before you move on to doing bindings on any other parts or anything else, you should just double check and make sure that you got all the bindings that you want. If you mess up your bindings early on parts here and you start adding bolts and certain things like that, you might get things that you don't expect happening. Like if you forgot one of your bindings and then you modify some parameters, things might flip out in your component and you don't know why. So it's always a good habit that when you do each of your bindings, do one point at a time and make sure that you've bound them all in the direction that you want. Alright, so let's go ahead and close the custom component. And let's go back to the model, and it sends us a message saying that you already have custom components applied to the model. Any of these changes, if you save and press yes, is going to update all those instances of the components in the model. So we're going to say yes. We're going to then go back to our 3D view, and here we can actually see that the plates all tightened up here to the column flange or at the toes of the column flange or the column web here on the like we see. So the reason why this one moved as an example is because again we bound the plate to be lined up with the boundary planes on the column, and so it won't go to the column web itself, but it at least did line up the plate with the toes of the flange there because that's where the boundary box or the boundary plane is. Now we also see that over here where the plate was down inside the beam because it was a different beam size, that's now fixed and all of the plates stay lined up. Now if I come in here to one of these components and I change this value to 16 and press modify, it modifies that specific instance of the component. I could select multiple components holding control and modify both if I'd wanted to. Now the neat thing here is that if you see any values that are basically in brackets, so if I select on this component, press get, or if I just double click on a component, if you see a value that has that's inside brackets like this 1/2 inch, that means it's using the default value that's inside the component. Here, this 1'4" doesn't have brackets, so it's something that we've manually overridden the default for. Now, if I just simply clear this out, press modify and get, you'll see that it goes back to the 8" default that is out of the box. Now, if you want to set defaults beyond what's hard-coded inside of the component, let's say you wanted 1" as the default and 12 inches here, and then if you come up to the standard for under the save as and say save as, then basically every time Tekla opens this model, it will use this standard set of properties, which is basically what you've entered here, rather than the built-in defaults underneath the hood. Now, when we go inside the dialog box and we try to change the thickness, notice when we press modify, nothing happens. And that's because we haven't parametrically linked anything from the dialog box to the actual profile of this plate. So if we open up the plate, you see that it still says 1/2 inch. Now, we have 1/2 inch by 12 because we're specifying both the thickness as well as the width of the plate. Let's say that we want the width of the plate to follow the column flange width and then the thickness to be based on the field in the dialog box. So let's go ahead and make that and edit that in our component. So we'll right click here and say edit component. Again, as a good habit, you should come in here on these 3D views or any of your modeling views and minimize. Only have the custom component editor views visible here. Okay, so now we're going to go ahead and select on our plate, and we can see that we have the input points bound, but now we need to deal with the thickness as well as the width. So I'm going to go to my variables list here, and what I need to do is I need to add a variable here for the width and then a variable here for the profile. And so what I'm going to do is I'm going to set the width as just a default value of 6 for a moment, and then here I'm going to switch this value type to profile, because we're going to string together basically this profile that we see here. So we're going to make this string based on the thickness value we have and the width that we have here, and we'll calculate. Now I'm going to change the labels in the dialog box, and I'm just going to say plate width. And I'm actually going to leave this to show, and I'm going to show you how you can do a intelligent default. But if you leave it visible in the dialog box, the user can override this. So you can have a calculated value as well as a user overridden value. And I'll show you here in a minute what that means. Now if we come in here, we're just going to say plate profile. Okay. And then basically the way this works is, again, we're starting all of our formulas with an equal sign. And we need to get the PL. So anytime you have a string that you're using and it's not a variable name, then we want to use PL, or sorry, use quotes to enclose that. So here we want that PL prefix enclosed in quotes. If we didn't have the quotes like that and we just put PL, it would think that it's a variable name or a parameter name. So we want this to just be a string of text. Then you use the plus symbol to string these values together. So the first thing we need is we need the plate thickness variable. So we're going to put P1 here. Then I'm going to do plus, and I'm going to put the X for the by string here. So PL thickness plus X, and then we're going to do one more plus, and this is going to be P3, which is going to be the width. Now when I press enter on my keyboard, you see that the resultant value is plate 1/2 by 6. So what we need to do next is here inside of our component browser, we're going to go to that part, we'll go to the general properties here, and we see that there is the profile property. Now we need to take this P4, which is this automatically calculated variable, and we need to link it parametrically to the actual profile property of the plate. The way we do this is we right click on the profile and we say add equation, and then we just simply type in P4 here, and then we press enter, and now you see that it's parametrically linked with the object in the model. So check it out. If we make this 8 inches, you'll see that it adapts the width. If we change this to 1 inch, it adapts that value. So let's go back to 1/2 inch here, and let's say 6 inches here. Now the next thing I'm going to do is that, let's say I don't want to have to enter in that width. I want it to always be based on the beam or the column width here. So what I can do next for that is I'm actually going to select on this secondary object. Then if I go underneath that, there's the part, and there's this profile properties. So what I can do is I can actually get the width of that part. So that's going to be the flange width. I'm going to right click and I'm going to say copy value as an example first. Now when I paste that in here, that's going to give me the exact millimeter value of that particular flange width. Now I don't want that hard coded. I actually want that to be parametric. So rather than copy value, I right click and say copy reference. And so what this does is if I make this a formula, start it with an equals, and then I just paste that value in here. Basically what's happening is this is a GUID of that part, so a unique ID so it knows that we're talking about the beam. And then basically here is the property that we're reading from. So this is just a special formula that says always read the width of this beam and use that as the value for, or the returned value here for this P3, which we can see is 7. Okay, so with that being said, we are going to see this on the dialog box. We've got the profile linked, and we should be good to go. Let's close down our component and go try this out in the real model. Okay, so we'll open up our 3D view, and here we can actually see the plates are all following the beam width, which is perfect. If we come in here, let's go ahead and see the plate width, which we can see it's brackets, so it's defaulting, so it's calculating it, right? I can override this if I want to. So if I say 12, it'll override that calculated formula and do exactly the value that I say. Now here on the plate profile, it is good so that way you can see what the different value types on the variables do. Like here, this allows me to select the profile, but I actually didn't want this to be visible. So when I go back into the editor, I'm going to set this to not visible because really I'm asking the user for the thickness and the width, and then we're calculating what this is. We don't need the user to be able to enter that in. So again, if I want to clear this out, we'll just do that and press modify. It then goes back to the calculated value. If we come in here and we change this to a W14 by 74 as an example, here you can see the plate width changes. And then as far as the thickness goes, if we just go back into the dialog box of the component, let's change our selection to component here. We can change this to 3 inches, press modify, and again you notice that based on the bindings and the position of the material, because we set the input points on the bottom and told the position to go upward, the thickness basically just goes upward away from the face of the beam. Alright, now let's go ahead and edit our custom component so that way the beams are actually cut back around the column flange there. And we're going to need to use a fitting to do that. So we'll right click and say edit component. We're going to minimize the 3D view here. So that way we make sure we don't add anything in there. And then let's go ahead and tile our views vertically here again so we're working in the component views. Now when you're doing a fitting, it's best to be like in a 2D view here. And so we're going to do the fitting basically in this front or elevation view. I'm going to go to the Edit tab here, and I'm going to go to the Fit Part End command. I'm going to pick the beam, and then what I'm going to do is I'm going to start here at this intersection. So I'm going to say Control left click, and then I'm going to right click and say nearest here, and then I'm just going to type in 1 to come in 1 inch off the face of the column. I'll then just go perpendicular to the bottom here, and now I have a new fitting object in the model. Now check this out. If I go into the component tree and go to component objects, notice that the fitting doesn't appear. If I press refresh, then select on that, you'll see that the fitting object now appears. So anytime you add any modeling objects here within the component editor windows, it's adding those objects within that custom component. Now, what we want to do is we want to actually bind this so that way it lines up with the face of the column. So whenever the column size changes, we always have this value here. Now what I might also do is I might give the user the ability to control the setback. So here we're just going to say beam setback. And let's go ahead and type in 1 inch. Alright, so we have that variable of P5 now. Now the next thing I'm going to do is I'm going to do the bindings. Now you can just grab an entire fitting and you can right click and say bind to plane and just bind it to, say for instance here, this boundary plane. But then it will always stay aligned with that. If you wanted something to be skewed, then you might want to actually bind the 3 points individually. I'm just going to go ahead and do the whole plane because I know this. I'm going to design this to only work with perpendicular conditions. So I'll just bind the whole entire fitting to that plane. So now we have the 1 inch variable here inside of our dialog box. We see that this D7 has been added, and we're just going to say equals P5. So that way it always reads the beam setback here. We don't want this binding variable to be shown in the dialog box, so we'll set the visibility to hide. And then back up here on the profile, when we were in the component in the model earlier, we said we didn't want that to be seen either, so we'll set that to hide. So there we go, we've got the fitting now in the model. And so if we close back out, say update all the instances in the model, go back to our 3D view. If we change this column size to say a W12 by 53 and modify, notice that the plates all follow the model or follow the column as well as the beam setback. So this is pretty awesome. Without any programming, just a little bit of logic and formulas and using binding, you have parametric components in your model. All right, the last thing we're going to do is we're going to actually bolt this plate to the beam. And so we'll right click and we'll say edit component. And again, we'll go to our 3D view here and we're going to minimize that so we're only working in our component editor views. Now what I'm going to do is I'm going to just go to the steel tab here and there's the bolt option. I'm going to pick the beam, then pick the plate, and then it says to middle mouse button once I'm done there. And I'm going to go ahead and pick the first position, which is going to be the end of the plate, and then the other end of the plate, and then I'll right click and interrupt. So now we can see that we've got our bolt there. Now what we need to do is we picked these 2 points, right? So this forms the x-axis of the bolt group. Now what we need to do is we're going to say the first bolt is going to be 3 inches away from the face of the column. Then let's say that we want a gauge on the bolts to be 3 inches here. And then let's say that in the Y direction we want it to be 2.5, just based on the beam gauge as an example. Okay, so now we've got some bolts that are input here in the model. Now before we come back to any of these parameters, what I want to do is I actually want to do the bindings, so that way the bolt group always stays centered with the plate and with the beam. Now just like the plate, because the picking points were almost exactly the same, what I'm going to do is I'm just going to hold down Control and select both these points, and I can actually do bindings at the same time. If I right click and say bind to plane, we're going to go ahead and go to boundary planes here, and we're going to bind to the top flange of the beam. So we get 2 zero distance bindings because we do want the bolts to stay lined up on the top flange, just like the plate is. Now let's go ahead and say bind to plane again, and let's do center planes. So I do want the bolt group to stay centered on the beam, just like the plate is. So we get 2 more binding distances added. Now, however, on the bolts here, we want this point to actually be lined up with the column flange face. So I'm going to say boundary planes there. But on this one, I'm not going to do what I did on the plate where I actually had that positive 8-inch distance. In the case of the bolt, we're actually going to tell this to follow the edge of the plate. So even though there is a parametric value for the plate length, if the plate changes, we're going to basically tell our bolt to change with it. So that way we don't have to add that plate length formula twice. So we're going to select that point, right click and bind to plane, and I'm going to bind to the boundary plane of the plate. Okay, so now if I go back into my variables list, we've added all these additional distances here. And so we just want to make sure that the number of our distances basically matches the total of 6 for the point. So we've got 1, 2, 3, 4, 5, 6, and you can see those highlighting in the model. And 6 comes from binding each point in 3 different directions or 3 planes. Okay, so let's go ahead and close the component down and take a look in the real model and make sure that this is working out. So here we can see that we've got bolts in all of the different conditions, right? And we can see that the bolts are also following basically the endpoints of the plate there. So we can see that. You can see that there with the edge. See that one there with the edge. Okay. Now over here on this bigger or thicker plate, we can see that the bolts weren't able to actually complete their solid. And the reason for that is because the cut length was too small here. So we actually need to specify that as a parameter, and maybe we want some controls over the distance and spacing on these bolts. So let's go ahead and do that next within our component. Go ahead and right click and say edit component. We will then go to our 3D view here and minimize that so it's out of our way. Tile the views vertically here. And then now what we're going to do is we're going to come in here to this bolt group, and we're also going to open up the variables list. So what kind of things do we want in here? Well, the first thing we might want to control is the bolt diameter and the bolt grade. So I'll add two parameters here, and I'll call this bolt diameter and bolt grade. Okay, and then here we actually need to change these types on the variable type. So, or sorry, the value type. So this is going to be bolt size and bolt standard. And you'll see here that there's these suffixes that get added. Now, one thing I want everybody to be able to see is that if you actually come in here and press F1 on your keyboard, this is going to open up the help in Tekla, and it's going to talk about specifically this variables list. What's really handy about this is it actually explains some of the different parameters or things that are in the variables list, as well as the different value types. So this is showing you here what I'm about to talk about bolt size and standard, and this special suffix that goes together here for these to work. So that way the bolt diameter you select also goes along with the bolt standard, because that ties to the bolt catalog. But I recommend definitely looking in the help and reading some of these things, because it also tells you what kind of formulas and parameters and variables that you can actually use in your formulas. So this is really handy. All right, so going back here, we can see the suffix. Now what we need to do is we need to make the P part of this name the same. So these two here, they almost interact with each other. So you have to have the prefix here, like this P6, the same, and then the suffix needs to be exactly as shown. So here on the bolt size, we'll just say 3/4, and then we'll put in A325N as an example for the bolt standard. Okay, we do want those to show on the dialog box, and now how do we link that to the actual bolt group? So again, if we click on this, we see the bolt is in the component objects in the component browser. We go to the properties and we look at the different properties here. Now we see that this P6 diameter is likely going to be the bolt size. So we'll come back in here, we'll go to size, right click, add equation, and we'll say paste, and there we go. Then when it comes to the grade, we'll just go ahead and say copy. And if you're not sure which thing that you're actually looking at here, if you go into the dialog box, what we're talking about is the standard. So size is the diameter, and see how it's a drop down based on the bolt catalog. And then the standard is the available bolt grades based on those diameters. That's why they're tied together. So we'll go to bolt standard here. We'll right click and say add equation, and we'll say paste. And there's the screwed in. So now this is parametric. So if I come in here and type in 1 inch, you'll see the bolts have now modified in the model. So those parts are now parametric. Okay, so let's do that cut length that we were talking about. And so if I go in here, the cut length was too small, basically for the for that really thick plate that we had. Now, as a good rule of thumb, I'm going to probably make the cut length basically the total thickness of the two plies multiplied by 2, or 1.5. I'm going to go by 2 because that'll make sure that the bolt is completely covered there. Just to do this really quickly, I'll basically go get the plate thickness. So this P1 value here, right? So I'm going to say cut length is going to be equal to P1 times 2. So we can do basic arithmetic here, and it multiplies it out. Now this seems a little bit small because of we want the bolt to actually complete, including the flange thickness. So if we wanted to include the flange thickness as a reference, we would grab this beam and we'd go to the properties here under profile properties, and we'd grab its flange thickness. We'd say copy reference. Okay, so we want P1 plus this reference, and we're going to multiply that by 2. Okay, so I'm going to add up the plate thickness and the flange thickness, and I'm going to multiply that by 2, and that gives me 2 inches. All right, so I'm going to call this cut length, and then I'm going to grab this P7 here, and I'm going to go over to the cut length in the bolt, and I'm going to say equals P7. So now, when we go inside of there, you can see the cut length is set at 2. Okay, so let's see if this actually works out when we go in the model. So I'm going to say that we don't really need to see the cut length because that's going to be a calculated parameter, so we'll hide that. But let's just close this, go back into our connection in the model, and now we can see bolts. Cool, so the cut length did work based on us calculating it with the flange thickness and the plate thickness times 2. And then let's actually open up our component here. So let's change our selection to components. And we can see that there's the bolt diameter. So I can go 1 inch and then I can select any of the bolt grades. So this is the advantage of that bolt type. Press modify and there we can see that's changed. Okay, so now we've got some of the basic parameters. Let's do one other thing with the bolts, which is going to be like those offset distances. So we'll edit the custom component and then we're going to go ahead and go to our 3D view, make sure that that's minimized and out of the way. And we'll just maximize this here again. So let's go back to our parameters list and let's add a few different things. Let's say that we want to do the bolt spacing. So I'll add a parameter in here called bolt spacing. And then I'll add another parameter called bolt edge distance. And that'll be to the end of the beam. So let's say that we make that equal to 2 inches and then we will do the bolt spacing at 3 inches for now. Okay, so then basically what I'm going to do is if I come down in here to my parameters on the component browser, so we'll select on this and then move this down real quick. We'll go to bolt. Okay, so we have the DX start. So that's really going to be the horizontal edge distance. So we want that edge distance there, but we also have a beam setback, right? So we did the first point of our bolt at the face of the column. So we need to include both the edge distance plus the beam setback value. So if we scroll back up here, I think P5 was our beam setback. Now, you can put formulas over here, but I always suggest to put all of your formulas in this list. So I want to show you two ways that you can do this, but I would suggest doing it the second way I'm going to show you. So I know that P5 is the beam setback and P9 is this edge distance. Basically what I'm going to be setting here is this DX start point value. So here there's a DX start. I can right click, add equation, and say P5 plus P9. And that would work. Okay, so you can do the formula directly there, but sometimes people won't see that intelligence or that link unless they actually go there. So I like to not do it this way. I like to actually come in here and add a parameter, and I like to say calculated. Okay, and we're just going to say that's going to be equal to the P5 plus P9, and there's our 3 inches. Then here in the DX start, I say add equation, and I'll do P10. So if I increase this edge distance here to 4, we should see the bolts move out like they do. Okay, so let's do the last one here. So the bolt spacing, the P8. So again, what we're looking at here is this bolt distance X. So we'll just go to the bolt group distance X, add equation, and we will say equals to P8. And so then if we change this to say 4, then we know that that will change the spacing on the bolts. Okay, so we want all those fields to show up on the dialog box. We don't need this calculated edge distance to show, so we'll set that to hide. And then we're going to go ahead and close this, go back to the model. And so here we can actually see now that we can control all of those values. So if you want to set any of the defaults for these, basically what you can do is you can enter in the values. And then again, you can just come back up here and save over the standard or type in save as here if you haven't done it yet. And now you have that default that's built into your component. Now, let's say we want to share this component with someone else or in a different model. If we right click and say publish, and then basically it's going to add a .uel extension and it's going to use the component name and it's going to try to export this UEL file inside of the model folder that you're in. So you just say save. And then if you go into another model or create a new model, basically in the component catalog over here, you just click on this button and you say import custom component and you select that connection UEL or that custom component, you open and it will then import that here into your applications and components panel. All right, so that is custom component connections.